So, there are a few different ways that you can solve a system of equations. And those different ways are graphing, substitution, and elimination. Today we're going to talk specifically about substitution. Okay? And just down here, let's write substitution is replacing something with its equivalent. Okay? Replacing something with its equivalent. Okay? We have to make sure that whatever we're replacing when we're solving this is equal to, it is the same value as what we are replacing. Because if you think about it, when you go to the bank with 20 $1 bills, you expect an equivalent of that back. So they're going to give you a $20 bill back. It will not be an adequate equivalent if they give you back a $5 bill and nothing else. Okay? So it's really important that we can make sure that we know what an equivalent means and that we plug in an equivalent expression for whatever we're replacing. And that might make a little bit more sense as we get into these 3 practice problems that I have written up here. But let's start first with looking at, let's just look at this first example here. So number 1 here. We always need to make sure first that we have a variable with a coefficient of 1 somewhere in this problem. And we do right here. Okay, we have 1y. All right. Once we have identified that, we also need to make sure that we can get it isolated. So it's the only thing on one side of the equal sign. And for us here, obviously, it's done that for us already. It is given to us. So that means that we already know that 6x minus 11 is equal to y. Okay? These are equivalent to each other. Okay? That's what that equal sign means. It means that they are equivalent. Okay? So that means that anywhere that we see a y, anywhere in the system of equations, we know that 6x minus 11 is going to be an adequate replacement. They are going to have the same value. So if we look down here at this second equation down here, you'll see we have a y. Okay? If we have a y, that means that we can take this equivalent that we just found, and instead of having y there, we can plug in our 6x minus 11 because we know that it is equal to y. Okay, it is equal to y. Now, why did we do this? Okay, when we are solving a system of equations is going to have, system of equations is going to have a solution of x comma y, a shared x value and a shared y value. The reason that we plug this 6x minus 11 into this equation is because we need to get this equation to a point where we can solve for a single variable. We can't do that when there's 2 variables there. We just can't resolve it. We have 2 unknown terms, x and y. But if we replace this y with 6x minus 11, we've taken away one of those unknown variables. Now we just have x and x. We can solve for x now. We can solve for that shared x value. Okay, so in order to do that, let's just start simplifying. Okay, we're going to distribute this -3 in for both of these numbers in the parentheses because this means that we're multiplying. So that's going to leave us with -2x. This is going to come down. Minus 18x, because -3 times 6x is -18x. -3 times -11 is a positive 33, and that's going to continue to be set equal to -7. Okay, then we can combine our like terms here, negative 2x and negative 18x. That will give us negative 20x, and then plus 33 is equal to negative 7. Now, we can't simplify anything else on this side of the equal sign, so now we have to start doing our opposite operations in order to isolate x. Okay, and we're going to start with the furthest number away from our x. So that's going to be this 33. Our opposite operation here is to subtract that, because plus 33, we got to cancel it out. The opposite of plus 33, in order to cancel that out, is minus 33. And we have to make sure that we do it on both sides of the equal sign. This is like our scale that we have to balance. That's going to cancel out. And we're going to be left with negative 20x equals negative 40. Okay, negative 7 minus 33 is negative 40. The last thing we need to do to isolate this x, we've got a negative 20 being multiplied to it. So in order to cancel out multiplication, we have to divide that negative 20 on both sides. Remember, we got to keep that scale balanced, and that's going to leave us with x equals positive 2. Okay, that's our shared x value. All right, what do we do with that now that we've found it? You may be asking yourself. Well, we have an x value. We know exactly what x equals. This is just a single number here, okay? Just like up at the top here, we knew that 6x minus 11 was equal to y. We knew that those were equivalent statements. They were equivalent expressions. We now know that x and 2 are equivalent to each other. What's the last thing that we need to solve for to get the solution is a shared y value. So we can take this equation here that's solved for y already, and we can plug in this x value for x. So instead of 6 times x minus 11, it is now 6 times 2 minus 11. We use that to solve for y. Okay, so 6 times 2 is 12. 12 minus 11 is 1. So that means that our shared x and y value for this system of equations is 2, 1. So our x value is 2 and our y value is 1. Okay, so let's take a look at the second example here. This one looks a little bit different because we do have a coefficient of 1 for x here, so we know that this is solvable by substitution. However, it's not isolated on one side of the equal sign quite yet. Okay, so we're gonna isolate that on one side of the equal sign. We're trying to get this entire term over here. So if we want to get an entire term over there, we want to make sure that the y goes with it. So we can't just divide this by negative 2 because then we're going to have a whole bunch of weird fractions. So we're going to take the entire thing. We're going to add the entire thing. It's going to cancel out on this side, and then we can bring it over there. So we're going to be left with x equals, now it is isolated on one side of the equal sign, 11 plus 2y. Okay, so now we have an equivalent expression for x. Okay, it is equal to x. These are equivalent statements. We can replace any x that we want in this system of equations with 11 plus 2y. So let's do that. Okay, we have in this equation here an x. Okay, so let's plug it in. Instead of negative 7x, it is going to be negative 7 times 11 plus 2y. And then our minus 2y equals negative 13. Okay, so now we distribute this negative 7 in to both of these terms. We're going to have negative 77. And the negative 7 times 2y is going to be negative 14y minus 2y equals negative 13. Awesome. Then we can combine our like terms. So that negative 77 is still going to be there. But this negative 14y and this negative 2y are going to combine together to get us a negative 16y equals negative 13. Okay, we've simplified everything we can on the left side, the equal sign here. So let's start by doing our opposite operations to isolate this y. We're going to start with the addition and subtraction. We're going to add 77 to this side. That's going to cancel out. And remember, we have to do it to both sides. So that's going to leave us with negative 16y equals positive 64. Because negative 13 plus positive 77, we're going to come out with a positive 64. Okay, the last thing we've got to do, the opposite operations to isolate the y. Now we have a negative 16 being multiplied to this y. So to isolate it, we got to divide by everything that's not that y there. Okay, so that's going to leave us with y equals negative 4. Okay, we now have our shared y value. We know that in this system of equations, if we were to plot this on a graph paper, both of these functions would have a y value of negative 4 somewhere. Okay, so how do we find our shared x value? Now up here, we have an equation that we solved for x. Okay, it's not completely resolved. We still have a y value there, but the great thing is we now know what y equals. Okay, so we solved for x, so x equals, and we can just plug this y value in for y. So plus, instead of 2 times y, it's now 2 times negative 4. So that's going to leave us with x equals 11 plus 2 times negative 4 is 8. So 11 minus 8 is 3. So that means that our shared x and y value here is 3, negative 4. Okay, so that is our answer to this one. Okay, and this last one looks a little bit different. Okay, we can see that we have two different variables, well, two variables, y and y. These are both variables with a coefficient of 1, and they are also variables that are isolated on one side of the equal sign. So why would this be different? Why can't we just resolve this as normal? The answer is we can. However, it looks a little strange. I want to acknowledge that. Y is equal to two different things, technically. However, because we have this unknown variable here, this is legal math. We can still do this math problem. So we can look at it a couple of different ways. Either you can say, well, if 6x minus 14 is equal to y and negative 8x is equal to y, then that means that they must be equal to each other. Okay, so then we can set them equal to each other. Okay, we can do that, but if you don't like that, if that was confusing, that's okay, because we can look at it a different way as well. Okay, we can also look at it as if negative 8x is equal to y, then that means we can just plug this in right up there for y. Okay, so we can plug this negative 8x in for y, because we know that it's equivalent, so we know that it can be substituted. It is equal to y. So we can plug it in for y, and then we can have the rest of our, that's not the right number, we can have the rest of our equation as is, because we didn't plug anything in for x, we just plugged something in for y. You can also do that vice versa, where you can plug in the 6x minus 14 for this y, but it's going to get you to about the same thing either way. Okay, so once you've replaced one of those y's with either one of its equivalent expressions, so in this case we took the negative 8x and replaced that y with it, now we can solve for x. The only variable that we have here in this equation is x. Okay, so we need our answer to look like this in the end. X equals. How do we do that? We need to make sure that all of the x's are on one side of the equal sign. Right now we do not have that. Okay, they are on two separate sides. So we're going to take this 6x, we're trying to bring this entire term, the whole thing, to the other side. How do we do that? We're going to do that opposite operation, because we got to do it to both sides of the equal sign. So if we subtract the entire term, because this entire term is positive, the way that we cancel it out is to subtract it. We're going to cancel it out. We're going to bring it over here. It is now on the opposite side of the equal sign. Okay, so that's going to leave us with negative 14x equals negative 14. We now have an x on one side of the equal sign and not on the other. Okay, so all we have to do now is isolate the x completely. Okay, so this negative 14 is being multiplied to that x, so we can divide it. And it will cancel it out on this side, and we will be left with x equals negative 14 over negative 14. So negative 14 divided by negative 14 is 1. Okay, and since we already solved for, well, we didn't solve for, we had two different equations for y equals. We can solve for y in two different ways. We get to decide which equation we want to plug this 1 into. I'm going to choose negative 8x because it's just got the least amount of steps. So instead of negative 8 times x, it is now negative 8 times 1, so y equals negative 8. Now, you can also do this for the other equation if you want to. We can also plug it in for 6x, so instead of 6 times x, it'll be 6 times 1 minus 14. Y will then equal negative 8 as well. Okay, so you can do it either way. Okay, but for the sake of keeping things simple, I'm just going to do it with the shortest amount of steps. So that means that our shared x value is 1 and our shared y value is negative 8. That is how you solve a system of equations by substitution.